In last session, we have seen basic data types, and now in today's session, we will see the some of the basic important concepts that are important for making our fundamentals much clear. Now, the first thing that we are going to look is memory. Now, understand one thing: whatever the objects you create that are stored into the memory, and whatever calculations etc are happening, that is also happening in the memory. So memory is a very important part when you are working with the R. Now let's jump to our R studio. Now we have seen how to create a different variables, so it's easier, like you create some variable, okay, like assigning some value to them. And now when you create these objects are automatically allocate some memory in your operating system, and then stored whatever values that you have created, okay, into this. Now sometime uh, you wanted, let's say if you're using the SAP, sorry, the R GUI instead of R Studio, and you wanted to see the what are the different variables or the memory objects that you are already you're using in R. Now R Studio, it's much easier because you can see immediately in the environment, okay, what are the different objects you have. But if you are using a normal R console, then to find out this, we have a function called as ls. Now ls is actually returns the list of objects that are there in the memory. So you can see we created two variables, one is x, the other one is capital Z, and when we run the function ls, it has returned uh, the list of the objects. Okay, so if I create one more object, and let's run the ls again. Okay, now you can see the another created object is also available in the list. Now you might be wondering, like, when we created this thing, these objects, what is the memory allocated by R? Now the easiest way to see what is the current memory size used by 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 R is by checking by using the function memory size. Now if I just run this memory size, it says it's using 76.79. And let's create few more objects. So okay, so I created a seven, and now let's see what is the memory size. And you can see it has been small amount of memory has been increased. Okay, so whenever any program runs, okay, the operating system allots him some memory, and as the requirement increases, the memory sizes get increases. So R also does the same thing. Okay, to clear this concept, let's see what is the memory used. Okay, so here now it says uh, 107.6 memory used by RStudio, but understand one thing, uh, it is all the R environment as well as the RStudio environment, so that consecutively it comes around 105.1 MB. So that's the reason. Let's jump to our console, uh, R console, and let's find out what is the memory used there. So it's 31.7 MB. Okay, and let's see what our how much memory is available for us. Okay, to create the objects. So, or right now used by R for holding the objects and other thing. So you can see here it's pretty nearby. So 27.38 and then this is 32.4. So very nearby. You have to understand one thing, that this GUI is consuming few memory. So adding that, the total comes to 32.4. Now let's create our first object. So I create once again here x 1 to 100. Okay, and now let's see what's the memory size. It's not so much increased because this object has been uh, you know automatically is taking very small size, and it has been used nearly few bytes. Now to how do you find out how much memory byte it has been used? So there is a function called as object size. Okay, and let's see how much our object is using the size. Oh, sorry, it's object.size. It's for 40 bytes. So this memory that has been shown here is in megabytes. Okay, so that's the reason we have not seen any much increase in the value. Now let's try to create a bigger object. So I try to create an object y, okay, which has a size of 1. Okay, I'm trying to create a you remember, like now this y will have the values from 1 to this big number. Okay, and the moment I hit the enter, okay, the y object has been created. Okay, and now let's see what is the memory used by this object. So object size y. Okay, so it's around this big number of bytes. And let's see now what is the change that has been happened with this memory. So now the memory has increased to 406. You can see here, earlier we was something around 32 MB and now it shows 412 MB. So in the R environment also it's showing now R is consuming 406.73 MB. Now as we keeps on creating the different objects, okay, this memory allocation to R will increase. So let's create one more object. Okay, now I this time I try to create even a bigger one. Okay, now you can see here that the time I try to create a much bigger object, R has thrown an error saying that okay, it is cannot allocate of this much amount of uh, memory, because let's see what is the size, okay, that is possible R to extend. Now why this function this object creation is fail is that when I was trying to create this object, it was requiring 74.5 GB of memory, and unfortunately my laptop is just holding something around 8 GB of RAM. Okay, so let's see what is the possible memory limit that is available. So you can find out this using function called as memory.limit. So here you can see here, okay, 8072 MB, that's the maximum memory that any in total we can get to create a new object. Now you can actually change this limits, and we will see this when we work with the performance things. But for now, just understand how this memory management things are working. Now okay, I create this now this z as a once again one more object, but now like x. Okay, I try to keep it small, sorry, like y. Okay, and now let's see what is memory size that has been allotted. It's now nearly double. Okay, so from 400 now it's 793.6 MB. Now let's see what are the objects in memory. Okay, so if I execute the function ls, okay, now there are three objects x, y, and z. Now to remove the objects that are already created in the memory, you can use the function rm. Okay, so I try to remove one of the object, remove z. Okay, and let's try to remove the y also, which was quite big in size. Okay, so I removed these two objects. Okay, now if I try to run the ls function, it's just say x, and if I try to access the variable y, it will say the object y is not found because we have removed it or we have erased it from the memory. Now see what is the impact on the memory for this. It still shows as 787.75. See here, it's still holding, this much size, because whenever you create any objects, okay, are a lot ask for more memory, and then it keeps that space available for a few more minutes, okay, so that the further amount of data, if it is loaded, it can easily acquire that space. Now there is a garbage collection job that runs in a background, and it keeps on releasing the amount of unused memory by hour to the operating system. Now this is happening in a background, but you can immediately release the memory back using the function gc. Okay, it is calling a garbage collector, so you can remember the function g for garbage and c for collector. Okay, and the moment I hit the gc function, now it will return back some statistics, that how much memory, you know uh, the details about the memory that it has possessed. And now let's see what is happening here. Now you can see here, it has dropped from something around 786 MB to 30.6 MB, exactly nearly to the same stage where we was earlier. Okay, and let's see in memory.size how much it says. Okay, 27.74. So mm, so let's go back. Now we have seen the few of the important functions. The first one is ls, which shows you all the different variables that are in the memory. Rm function to remove any object from memory. Then I forgot to mention the function gc here, but that we have seen the garbage collector, okay, which removes and sorry, give back the unused memory to the operating system. And you should do it whenever you try to destroy a bigger object. So in future when we write a complex logic, okay, we may have a lot of values that are stored in a memory, and when we delete this type of objects, it's important that we run this gc function manually, or include in your code, so that it releases the memory back to the operating system. And then we have seen these three functions: object size, memory size, and memory limit, uh, when we are working with this memory. Now let's go to the next topic, working with the directory. Now the whenever you create any when we start creating any programs, okay, we will be definitely using the creating a new project and creating our files. But you wanted to understand right now where you are running, okay, what is the current folder that has been accessible, okay, in which folder you are working. So you can use this function called as get working directory. So it is short form is getwd. Okay. Now it will return in which folder the currently this R session is running. Now I don't want to work in this folder because there are a lot of files, and if you want to see this, okay, which are the different files and directories available here, you can use a function dir. Okay, and you can see it's listing down my the folders as well as the files that are available in the R. Now I like to keep my all source code in my R folder. Okay, but for this session, let's create a new directory. Okay, and in this directory we will create our files, or we will see how we can work with it. So to create a file, it's sorry, to create a folder, it's very simple. Just say dir.create. Okay, and let's create a folder called as test. Okay, and now let's see if what happens when we say once again call this dir function. Okay, and you can now see there is this folder entry is there. So it says test. And now there is another way. Let's say when you are writing the scripts, okay, and you are trying to save your results into different folders, it would be important to use this function if directory exists. Okay, and if I try to see if I is there any directory with test, yes, but is there a directory with test2? No. So when you write your script, you can write the script in such a way that, okay, if particular folder exists, okay, then dump my file. If it is not, okay, means dir.exist. If it is doesn't exist, okay, create a new folder. So this is how this dir folder can help you. Now let's change our current working path to this new folder that we just created. To do that, it's very simple. You have to use the function set wd, that is a short form for set working directory. Now get working directory has returned you this path. Okay, and now to set a new directory, I have to just enter the new directory name. Okay, and if I can give the complete path, okay, if it is totally different, but just because this was I wanted to change one directory in the current directory itself, I have just entered its name. So you can actually give complete physical path like this, or you can just say set working directory and the shortest logical path. And let's try to see what is the current working directory. And now we are actually in C drive users, Janth, .dhavle, then documents and test. So these are the a few of the basic functions, okay, that you will be using while to set a directory, the set the current working directory, to retrieve what are the different files and folders available in a directory, then to check if a particular file or a folder, sorry, if a particular folder exists, and if it is not, then how to create it, and then once again how to change your current working directory path. Okay, now we have come to the next topic, that's input and output. By default, R starts interactive sessions with input from keyboard, and then the output is always on the screen. But this is not the case always. Okay, you might wanted to create your program, okay, and you save that program into some file, and then next time you don't want to write everything once again, you can just want to run the particular R script. So let's once again jump back to RStudio and let's see how we can do this. So let me create one script file. So I say file, new file, and then R script. Okay, and then let's create a variable var1. Okay, and I store some value 100. I create another variable var2. Okay, and then I stored some another value, and then I create var3, which is just a multiplication of var1 and var2. Okay, and then I just print the var3. Okay, so this is my, let's say, a simple file that I created. Okay, which doing this calculation multiplying 100 by 2 and displaying the result. Okay, so to save this I will just click on save. Okay, now you can see here it has automatically took the current working directory path, and I create save this as a test.r. Okay, let's yeah, so save it as a test.r and let's save it. Okay, so our script has been saved. Now let's load it in our memory. Okay, so from RStudio you can always use this source function, source button to load it, but from the command prompt if you want to do that, just say source and then the file name, that is test. Now here RStudio has a one more advantage, that you can just press control and space and it will for you it will try to find out which is the file available, or if you just put the code, okay, and then press the test.r. Okay, it is come automatically because currently there is only one file in my working directory, but if there are multiple, okay, then you will see a drop down here. Okay, and that drop down you can actually select the file. So this is a function that can load your code uh, into R. So that's it. So here you can see var1, var2, and var3 has been created, and the results has been also executed to in your environment. Now this is what happened when you executed the output. But now how about the thing, like whatever I am doing right now here, I wanted to save it into that particular folder. So let me try to save whatever the text output that comes on my screen, okay, to file directly. So to do that, you have to use a function called as a sync. Okay, so sync, and then I create a file name, say output.txt. Okay, and then let's try to do some calculations. So what I do is I do var3 divided by var2. Okay. Now see here, it has not written any value here on the screen, because whatever the calculation that is happening, and and the result is stored into that file. So now onwards, whatever commands that I'm giving here, okay, the results are not shown on the file on the screen, but rather it would go back and sit into my file. So one more function I use dir to list down the files, and it has gone and sit into that file. So now you remember we have given uh, uh, two commands. Okay, so let's see where is our file. Yeah, test. Now you see here this test.r that we created, and then the output.txt. Now here you can see the first calculation, Okay, that is 100. And then the second command that I have given, that is output.txt and text.r, that is come from the dir command. Now, sometimes you don't want this append behavior. You can actually override the file with every new result. Okay, and to do that, once again, you have to use the sync function itself. Okay, but then you have to pass on some other parameters. So output.text, okay, comma, and then there are another few things. So one is your append, so it's always true. Okay, so if I set it to false, okay, so let me set false. Okay, and then let's try to run any other calculation. So I'm doing 1 2 3 4 5 7 8 9, and let's see what's happened with our output.txt. See, the earlier values has been now overwritten with this new value. So if I run any other command, okay, that output will be also get overwritten, because now we have sent the append as false. Now sometimes you want both the outputs. So now okay, let me use this control space and then select the first function. Okay, the first parameter, that's the file name. Okay, now you see here I put it the ports. Okay, and then I press the control and space. Now I can give my file name output.txt, and let's set the append once again to the true. Okay, and now I use this function parameters split. Okay, now this is useful whenever you want to see the output on the screen, as well as you want to store the values in a backend text file. So I set it by default, it is split is always set to false. Okay, so it either goes the output to the file or to your screen, but now I set it as a true. So now whatever the commands that I give, so I do the multiplication of x, okay, multiplied by 20, okay, and then the output, oh, strange, the output should come. Now you can see the value 200 is now printed on the screen instead of going back to the file. Now this has happened with the results. Okay. Now what about the plots? So let's try to draw a chart. So the command is plot, and let's plot this Z, which has 10 values. Okay, and I make it as a type as line. Okay, you remember this from the earlier videos. Now this straight line graph has been created. Now this plot has been shown on the screen, but what about if I wanted to save this plot on my into the file? So there are different functions that are supports. Like you can save your plot as a PDF file, you can save your plot as a JPG or a GIF file. So let's see how you can do that. Okay, so let's redirect this our the chart back to a particular file. So let's me try to create into the PDF. So I say okay, line dot PDF. Okay, and I clean the chart here. Okay, just to show you what is happening when I run this. Okay, now you see here there is nothing nothing drawn here, but instead of that, okay, there would be a file that would be created in my folder the moment I stop sending any output to to the screen. So there was a folder that was test. Okay, and now here you see line.pdf has been created, but there is no data that has been stored yet. Okay, it would be stored the moment I inform R that okay, whatever file output that I have done, and now I want back the control to my screen. Okay, so to do that, okay, you have a command called as dev. So you are actually telling graphics that whatever that has been putting in the file, now stop it and get back the output to the screen. So if I say plot z, okay, now the graph is once again drawn here, nothing. And now if you see this, the data was returned to the file and the graph has been drawn. Now same way you can use let's create a png file, okay, for our graph. So to do that, I will use the png function, and then let's say image dot png. Okay, that is a file. Okay, see here, 0 bytes. So everything it started, and let's try, okay, do the same thing that we have done, plotting the graph. Nothing is drawn on the screen, nothing is written to the file yet. And let's get back the control. Okay, so here you can see the immediately this has been written. Okay, and then the graph is written into the file. Now unless you do this device.off, okay, the output will be keeps on sent to the file, okay, and it's kept in the buffer, okay, until you put this dev.off. So it's very important to remember this thing, okay, whenever you are writing to the file. Now let's go back to our input output. So see, these are the different ways you can save your files. So PDF, PNG we have seen. The other way is JPG, BMP, win.metafile, and postscript. Now win.metafile is exclusively available with Windows machine, okay, but the others can be used with different operating systems. Now, before we close this session, okay, I wanted to talk about these two, ways in which you can save the objects as well as whatever the history that has been done till now. Okay, so let's clear out everything. Okay, so if I can just press Control L, okay, whatever that has been done, that has been cleaned out. Now if I wanted to see what are the earlier commands that I have given, okay, you can see this using the history function. So when I hit the history, by default last 25 commands that has been executed are shown here. Okay, if I run it in in RStudio, you can easily jump to this tab, but here, okay, you can, it is very useful when you are using the R console. So if I say history, okay, and it has been showing me in a new window the last few commands that was executed in this. Now it is showing the last 25 commands. If I wanted to restrict it to maybe only few of the last four commands, okay, then you can see the last four commands that would be executed are shown. Okay. Now, how do you save your history? So you remember the moment you try to close your R, okay, it will ask whether you wanted to save this. Okay, so you can save it to the file, or you can just ignore it. Okay, but if you want explicitly save this history, you can do this by function save history. Okay. Now, by default, the file name is .r.history. Okay, that is get created. But if you want to save it in some other name, okay, you can give the another name. So I just say history.txt. and then you know uh, a file has been created. Okay, if we just see here, the history.txt file is created with all the different commands that I have run in my R console. Now this is pretty useful. Let's say if you are doing some analysis and you want to save it, you can do this using this history, save history function. And when you have a clean history session, so you wanted to load it from some other file, this history, you can always use the function called as a load history. Okay, and then give the file name. I will use this control space to select the file. Okay, and then I load whatever the history that was there in this file. So you can see here it is once again loaded. So
Okay,
this
the
is
last
about the
thing that we
history.
will try to see is
Now
how
some
do we store objects into the file. So now we have these different variables that are available here, and I wanted to save them, few of them into this to the backend file. So I can do that using the save function. So when I say save, okay, and then you can see here it's a list that you wanted to pass. Okay, so let's try to save a different object. So I wanted to save first the object z, and then also object1, which contains these three characters. Okay, now the important thing is that you have to pass on the file name. So I create file, okay, and I say give it name as object.txt. Now in fact, when we save these files, okay, it's actually saved in binary format. Okay, but I'm just giving this name as .txt so that we will see what will happen when we try to see this file. So let's jump back into our folder where we have this files. So, um, test, okay, and here you can see that there is this object.txt is created, but it's in completely binary format. Okay, and now let's do one thing. Let's clear out everything. Okay, let's delete this objects obj1 and z. So I can do that using this command remove that we have seen earlier. Okay, sorry, it's a capital Z. Okay, that was already deleted. So now you can see these two objects are missing here. Okay, and to load it back, okay, you have to use the function load, and then in file you have to give the file where you have saved your object. So I think we saved it in object.txt. Okay, and the moment I hit the enter, you can see by this object1 and z1 is created back. Now in case you wanted to save lot of data, okay, you can or all the environment functions, there is another uh, function that is save.image. Okay, and usually this is file with created. If you don't give the file name, it's .r.data. Okay, so here I am not passed any name, and let's see what happened here. Okay, you can see here there is r.data file has been created. Okay, now that we cannot see the content because it's binary format. Okay, but let's clean out our all this global environment. You can do this with remove. Now I will pass the list function to it. Okay, and let's see what's happened. So sorry, you have to do this remove. Okay, and then to this list, okay, I give this function ls. So now list is actually returning a list of values, and that's passed to this remove function, which actually clean out all the environment variables, and nothing is there now in our environment. And just to load it again, okay, you know how we can do this. You have to use the function load. Okay, and then we have to use the file. that's dot uh, our data. Okay, and it's once again loaded. So we have seen the basic input output functions. I think that's all for today's session.